Okay, in this exercise, we're going to take a look at a part that has a 3D surface on the bottom and then has vertical walls. So it's a pocket with a 3D floor, but no draft wall. So if I turn on Get Draft Angle and check these walls, I can see that they all have 0 draft. In addition, this floor here, if you look at Solid Inquiry, has a large radius, just a very simple 3D shape on the floor, but vertical walls. Now the issue here typically is that is number one, finishing the vertical walls, and then 2, finishing the floor without smacking the finished walls. In addition, I need to know what this radius is, so that is an 1/8 inch radius, so we can use a 1/4 inch ball mill here. So if I turn on my tools and my cam, and I can see that I've already got a 1/4 inch ball mill made up, so we are good to go there. The other thing is this part, I believe, has a stock body. Yes, it does, has a stock body. But I don't remember if the stock body actually leaves stock or not. So I'm going to select this model. Oh, and by the way, as we work through this, we're also going to hit on a few little tips and tricks that really aren't particularly specific to the toolpath that we're creating. So what I want to do is I want to compare the stock body to this body. Even though there's absolutely no toolpath created, a lot of people know this tool that I'm going to show you, but they don't really realize that you can use it like this. So since we have a stock body created, and if I select my finished part model and I go to my Op Sim, again, there's no toolpath created yet, but if I go to Analyze Cut Part and select Remaining Material on Part Body and hit Show, I can see that yes, there is stock remaining on this. This part, when I begin my toolpath, is going to be as though the part has already been roughed and all we're dealing with is finished toolpath here. There are some options for how to machine this, but the questions generally are how to finish this wall without getting into this floor, but machining all the way down to that floor. So let's take a look at that. So I'm going to bring the 1/4 inch ball mill down as my finishing tool for the walls. I'm actually going to use this for finishing the walls and the floor. But I'm just going to do a contour, just a plain Jane geometric contour. Again, I'm not going to pay, as in most of these, I'm not paying any attention to feeds and speeds. So what I want to do is go to Finish Size, and we're going to run into some issues, and we'll address those as we go, because I found the best way to teach is to show you the problems that you'll run into and then try to methodically or step-by-step work through those issues. For my final depth, I'm going to hold down the Alt key and click on this surface, which will give me the lowest point on that surface. Not as deep as I thought it was. So we're going to go to this depth, and actually I'm going to go just a shade deeper because of the strategy that I'm going to use. I want to make sure that this tool can go as deep as it needs to go and possibly deeper. So what I want to do here is select, actually I'm just going to right click and select tangent faces and get all of that. I want to make sure that the surfaces that I want the tip of the tool controlled by are selected. So that's going to be either this or the bottom of the radius, either way you want to look at it. With this tool brought down, process open, I want to go to the Solids tab and make sure that Project 2D Toolpath is turned on. So we're going to machine geometry, or in this case actually the profiler, and then but project the toolpath against the yellow or the selected faces. So let me open this back up, and I'm going to make my first mistake. I'm going to go entry exit of 0.1 and 0.1, numbers that I typically use. I'm going to go to a top view, and I'm going to select one of these, which this is the mistake. I'm selecting actually the lowest point on this, and I deselected my faces, so let me reselect those. And again, just having that floor selected would be enough, or just having that radius selected, because the center line of the tool is going to be right at the intersection of this face and the fillets in the corner. And sorry, I'm getting stuff selected that I don't intend to select. All right, so this is going smoothly. All right, so we're going to climb mill. Last time, select the tangent faces. I'm starting, notice the problem that I'm going to have is that I'm starting at the lowest point here. I've got an entry-exit move. So I say do it, projecting the 2D toolpath. We've got several issues. The first one that I want to address, just ignore the corners for a minute. We'll get to those in just a second. But notice that since I'm starting at my lowest point, this entry-exit move here is going to gouge because it's going to be at the depth that the toolpath would be here, but it's actually coming into a part that's elevating here. And just in case I didn't really make that clear, let me turn on my edges, deselect the toolpath, and go to a front view real quick. And you kind of see the shape of this. This is looking at it from the front, so we're starting over on this wall over here. So you can see that the toolpath, the entry-exit move is going to be fairly flat. And even if it's projected down, I don't really want it running down that surface. It's going to leave a witness mark. So what I want to do, if I load this back up and turn my edges back off, go back to the top view, I want to start pretty much as close to the peak of this floor as I can. That way, as the entry-exit move come on and off over here, they are going over a lower portion of the bottom surface. So let's select the tangent faces again, starting up here. And in addition to that, another little hint, I guess, is I'm going to modify my entry-exit move. I really don't want this drastic type of entry-exit. So I'm going to come over to, sorry, bear with me. I'm going to come over to Advanced Entry-Exit and go to my Entry-Exit tab. And on my Advanced Entry-Exit, I am going to do Advanced. And what I'm going to do is an entry radius of, let's say, 3/4 of an inch. But I only want that to come about 50 thousandths off the wall. And really don't need the Z-ramp here. I could do Z-ramp if I wanted to. And let's just redo and see what that entry-exit looks like. So now you can see we've got a lot less drastic entry-exit. Now, if I wanted to, I could also give it a line, a cutter comp line if I wanted to. So I could say, give me a CRC line of 50 thousandths, just so that we can pick up cutter comp. And let's make that a perpendicular line. There we go. So now we've got a line to allow it to pick up cutter comp. That should be well clear of the floor because it's sloping down from this peak here in both directions. So that takes care of that issue. But the other issue is we have the retracts in these corners. Now we've talked about this before, but essentially if you imagine the toolpath, or actually the toolpath is calculated based on a triangle mesh. So if you imagine as it, the lines are fine because all those little triangles are flat coming through here. But as it comes around this corner, or around this radius, anytime there's a radius and a vertical wall, you have nested triangles forming the underlying toolpath calculation surfaces here. So what happens is it sees a flat area, and so it cuts, but then it sees where two flat areas come together, and that's actually impinging on the toolpath area based on the tolerance that you have set for your toolpath, and so it retracts to avoid gouging. Virtually every toolpath in every package that I've ever used has some level of vertical wall sensitivity, which is what this is called. And there are a number of ways to work around it. Kind of the old school way, and a lot of people call it cheating, but to me it's the fastest way to deal with this in this particular situation with a vertical wall where I'm projecting toolpath, is simply to lie to the software. Now this, may not always be appropriate. There are other ways to deal with it, and we'll look at some of those here in just a minute. But in reality, in this situation, I would just temporarily describe this tool as being 240 instead of 250 thousandths, and come over to my process and tell it to leave 5,000 stock. So what I did is I left stock, positive stock, which keeps the tool away from that wall, equal to the radius difference in the tool description and the real tool. So the real tool is 250. I told it that it's actually 10,000 smaller, so that's going to move, that factor would move the tool path toward that wall 5 thousandths to make up for the 10 thousandths difference in diameter. And this is telling it to stay 5 thousandths off. So that means that the center line of this tool is going to be in the exact same location, but it's now not detecting that the edge of the tool is touching that vertical wall. Again, yes, this is a workaround. Yes, it's not going to be appropriate in all cases. And yes, if I want to change this tool path later, I need to remember that I need to adjust that tool temporarily. Once the tool path is created, I change the tool back to 250 so that I get an accurate rendering with what's really going to happen on the machine, but I do not recalculate the tool path. If I recalculate the tool path with a 1/4 inch tool, I'm going to get the retraction in the corner again. So let's just take a look at this simulation real quick. If I slow that down and play it, you can see that we finished that. Now, what you might want to do is finish or almost finish the walls, then finish the floor, and then come back and do the final cut on the wall. But the process would be the same. So let's look at machining the floor. I'm going to click off there, click off here, and bring this tool down. I've already cleared that out. Bring this tool down, and let's look at a couple of solutions here. I'm going to go to Advanced 3D, turn off the profiler. So in Advanced 3D, I'm going to cut this and probably these. I probably could have just selected. Now let's do that. Come down to Select Fillets. Sorry, I've got a dialog that you can't see in my way there. So we're going to select Fillets, which actually got more than I wanted. So I probably would have been better off just to have kept selecting the fillets that I wanted. It also got these corners here. All right, so this is what I wanted selected. This is what I'm going to machine based on. I'm going to use the Advanced 3D lace cut. Again, I'm not paying any attention to speeds and feeds. I'm going to give it a 20,000. Let's go ahead and go to finish. I'm going to give it a 10,000 step over. Let's see, we're cutting everything from 0 to 90 degrees. I'm doing a raster style lace cut, which is just back and forth, a linear lace cut stepping over this amount between passes. Clearance in, clearance out, top of the part, or by toolpath calculation depth, and the Z level, the maximum Z level this tool is going to go. I usually do on these surfacing style toolpaths or anything where I'm basing the toolpath or projecting the toolpath onto a solid, I usually give it a little extra than the actual lowest point that I can measure there. We're going to go back and forth. Our cutting angle is 0 degrees, so it's going to be linear along the x-axis. The toolpath is going to flow left to right, and then since I'm going back and forth, left to right, then right to left. Then on my boundary, I want to make sure that this is set to silhouette. Again, we've talked about this before, but part bounding box essentially draws a rectangle around the yellow faces. It just pulls it in from the outside until it just touches from each side. But that comes to a corner here. So essentially, these corners are included in the toolpath calculation. Now, depending on some other settings, it may not actually create toolpath there, but it could. It could come out and try to create a pass up here all the way to these corners. Stock bounding box does this, and a lot of people think part bounding box draws a bounding box around the entire part, but it's really a bounding box around the selected faces as viewed from the machining coordinate system that you're working in. Stock bounding box does the same thing to your entire piece of stock, which would be the outside of this part in this particular case. In a situation like this, I usually use silhouette. And my boundary mode, I'm just going to let the edge of the tool go to the boundary, which is all I need. I need the edge of the tool to go to the edge of the yellow place, the yellow area. My stock type is solid, and I'm just going to close this, and we're going to get some undesired tool path here, but that's kind of the point, to show you how to fix that. There is a setting that I would have normally already gone to and adjusted, but I have not done that yet, and a lot of people aren't really aware of it, so I will include showing what the problem is that we're trying to resolve, and then how to resolve that problem. And this tool path will probably take, let's just see where we're at on this. We're at 36%, so I should have left that at a larger step over, but we're getting there. We're at 68%. And if you've watched any of my other videos, you know that I'm not very good at talking about nothing while it's calculating. So if there's some dead air, if there's some silent areas, I apologize for that, but just bear with me. I'm not going to edit the weight out of the video because I want you to see what toolpath, what kind of time toolpath calculation takes. Okay, so we run into the same sort of vertical wall issue here that we ran into with the contour. In Advanced 3D, very often the easiest solution here is to go to your Options tab and just tell it to remove spikes. And typically, you have a choice of removing only the end spikes or all spikes. In this case, all of our spikes are at the end of a stroke anyway, so I'll leave that checked. You can set a maximum acceptable angle and a non-spike allowance. So if it only comes up off the floor a small amount, you can have it not remove those very short spikes. Also, I would make sure that Fit Arcs is selected. It already is, but especially since this is a largely circular tool path, there's a very large radius on this. I want it to fit arcs. It'll make my tool path significantly shorter. My tolerance, I'm typically going to set to a larger amount if possible. Something larger if I have the tolerance to play with. The larger this number is, the fewer circles it takes to fit from one side to the other. So a lot of people make the mistake of making this a 1/10 tolerance, which basically eliminates the whole purpose of it, which is to reduce the toolpath size by combining short linear moves into longer circular moves where it can fit a circle or an arc into the toolpath. I'm just going to leave that at 1/1000 for right now, and I'm going to say redo. Remember, we hit remove spikes, which are those jumps up at the end of the strokes. Now, this will not always get rid of all the spikes, but oftentimes it will. A lot depends on what is causing the spike to be generated. In this case, it's because of these radiuses and that same vertical wall sensitivity that I talked about with the contouring process that we did first. So after this, we're going to look at another way that we might consider the tool path for this floor, and a couple of controls there that a lot of people are unaware of. We're going to use the surfacing lace cut, which I've seen and heard a lot of complaint about surfacing lace cut not being any good because of it dropping all over corners and things like that, dropping over this side of the cut. And you see this is some nice clean toolpath. That is some pretty decent looking toolpath. So that's how I would approach it, probably using the Advanced 3D. Let's close that. Let's get rid of that toolpath, and let's clear this out, and let's start over on that floor. I'm going to bring the tool down and I'm just going to do surfacing with it. So here, a lot of people would use surface flow cut and just select this floor. And that would work actually probably pretty well here because this is a single surface. What we want to machine is a single surface. However, we have less control over surface flow cut. And if we selected multiple surfaces, the surface flow cut really is not really appropriate, definitely not to my liking, because it almost never will combine surfaces to machine over multiple surfaces, because its function, its purpose is to machine a single surface. That's why this doesn't say surfaces flow cut, it says surface flow cut. So you can select multiple surfaces, but it'll typically cut those one at a time. So a lot of people really overuse this. They try to use it in situations that it's not intended for. Now, the exception to that is fillets. If you have a series of perfectly tangent fillets that are perfectly the same size, very often surface flow cut will treat them as a single surface. But that's the one exception that I'm aware of. So what I'm going to do here is I'm going to do a lace cut. I'm going to leave it fairly similar to the other one. Finish size. I'm going to do a variable step over, which I almost always use for 3D parts, even though it's really not going to affect this particular part because we're not coming up the walls. But I still typically just force of habit set that to variable. Now, let me back up here since I'm doing some tips and tricks as I go through this. This section is called cut width, and you can have a fixed cut width or a variable cut width. A fixed cut width locks in the step over. That's why that highlights when I click fix, it highlights the step over. That locks that in, so every step over, regardless of the angle of the face, is going to be whatever is set here for the step over. So if you look at your toolpath from the top, it looks all really even. But if you had a more extreme 3D surface here, what you would find is that as you kick this around and you look at the steeper areas, like if we had this selected and the tool was small enough to create some toolpath here, you would see the step over in 3D space getting much larger, because in order for it to step over, in this case 17 thousandths, in the XY axis, it's got to come up significantly in the Z axis to accomplish that. So your actual step over between one stroke and the next, measured along the surface, is much larger, which means your surface finish deteriorates as it comes up a more vertical wall. So this is a toolpath that's controlled by cut width, by XY step over. And toolpaths that are controlled by XY step over typically are better for flatter areas rather than steeper areas. Toolpaths that are controlled by step down are the opposite. They're typically better for more vertical surfaces, but they tend to the surface finish deteriorates drastically as you get to flatter and flatter surfaces. That's why a contour toolpath doesn't work well when you have a fairly flat area that it's looking at. All right, so variable step over, when I click it goes to ridge height. What that does is it locks in the ridge height. Now this is fairly old toolpath, but it's still in the software because for what it does it very, very well and very, very quickly. So what variable step over does is lock in the ridge height. So looked at from the top, again, if we were selecting some of these near vertical or vertical faces, what you would see is very consistent toolpath across here, but as it gets to the more vertical sections, you'd see the toolpath get closer and closer together looked at from the top. But when you kick it around at an angle, in 3D space, your step overs are going to remain much more consistent. What this does is it analyzes the steepest area along that stroke and bases the step over, the XY step over, based on the angle of that section of toolpath. So with all that said, we're going to step over 10,000, same thing that we did on the other one. We are going to go to our options page and select one finish pass on all surfaces. And now here is the next tip or trick. If you select lace cut and you do not get the toolpath that you're looking for, if it's dropping over an edge, or cutting an area that you're really not intending, I tell students typically that 90% of the time, and that's just a wild guess, but some very large percentage of the time, to get the toolpath you're looking for in a surfacing lace cut, come to your options page and make sure this box, this box, this box, and this box are all unchecked. So I'm going to uncheck all 4 of those. Now there are definitely times when one or more of these 4 boxes needs to be checked, but I would say a very large majority of the time, all 4 of these boxes should be unchecked to get what you're trying to cut, where you want your tool just to go till it's centered up on the surfaces that you've selected. All right, so with that done, I'm going to hit do it. And again, I've got to try to talk to cover the dead air. So we are calculating away, and we don't see as consistent of a number here because it's basically calculating each stroke. What we're seeing there is the calculation of each stroke. All right, so here we have some pretty good tool path with a handful of spikes. And these spikes are where the tool, the software realizes that it's coming into a vertical wall here, because the radius on this tool exactly matches the radius here. So there are a couple of things that we could do here. First off, a lot of people will go to no retracts. Now be aware that no retracts does not always generate no retracts. It still depends on the distance that it's traveling to get from the end of one stroke to another, which if that fixes it, then that means that the issue wasn't the vertical wall sensitivity. You can see we actually got more retracts here than we did the other way. And the reason for that is this selection here only applies to step over retracts. So it's calculated based on how far the tool has to travel from the end of one stroke to the beginning of the next one. That's not what we're seeing here. We're not seeing retracts due to that reason. So if maybe in these corners where it's moving at an angle, and these may be retracts due to step over, some of these, especially right here, where it's from the end of this stroke to the end, beginning of that one. You can see this one is not quite that way. It's during that step over move that it detects that retract is needed. So this is not applying to this issue. So I'm just going to move that back to long step over. But as another tip, there are times if your retracts are due to the distance between the end of one stroke and the beginning of the next, and no retracts, I often say no retracts is a lie. It does not eliminate retracts. It just basically sets this number on long step over moves to a larger value. I don't know what that value is. It may be 5.0 or something like that. But I have found that there are times when no retracts still generates retracts, and I can select on long step over moves and make this like 10, where it's 10 times the step over before it retracts, and that very well may eliminate it. But there are other considerations. For example, these retracts are not due to the length of the step over. So even if you deal with the retracts that are caused by the step over distance, you may still have retracts that are caused by something else. These are caused by that vertical wall sensitivity. So let's just recalculate that one more time here with a long step over move set, which is how I would normally leave this set. And I just realized this video is getting pretty long, so I will try to wrap this up kind of quickly. All right, so here we're kind of back to what we originally had. So what I want to do here is I want to tell the tool to stay slightly off of these vertical walls. So what I can do is I can come over here, and if you look at your do it and redo buttons here, to the right of those, you've got 3 icons. Actually, you have 4. You have a kick out arrow here to pre-select face definitions for 5-axis, so you can actually select your your starting surface, ending surface, and drive surfaces and all that sort of stuff ahead of time using this kick out here. But what I'm going to look at is these 3 buttons. This one is the normal. That's what's how it's set right now, where if I select a face, it turns yellow, meaning it's a drive surface, or it's the surface we're creating toolpath on. It's the selected surface. But the red one allows me to define faces as being what's called a constraint face. And then the blue one allows me to define stock faces. In this case, I want to define constraint faces, and I'm just going to try just getting the vertical walls. Now, in a lot of cases, I would also get that fillet in the corner, but here I'm just going to select these faces. And what this allows me to do is use these as constraint faces, in other words, to constrain or to limit the toolpath. So with those selected, I'm going to go back to the yellow and select that face. I held down the control key there. I'm not really certain if that's necessary, but I did. So I'm going to create the same toolpath, but now I can tell the tool how close or how far I want it to get or stay away from the red faces. So to do that, I'm going to open this up, and right here I have constraint face clearance. So I can say stay, let's just try 1/1000. So I want it to stay 1/1000 away from the red faces. However, my constraint face tolerance is set to 5/1000. So the tolerance of how accurately it displays those is, being greater than the amount I'm staying away from them, means that I'm probably not going to eliminate all those spikes. So let's drop our constraint face tolerance down to, say, 1/2,000. Thousandths would probably be fine, but I want it to be significantly smaller than the distance that I'm staying away from the constraint faces. Let's recalculate this and see if that eliminated spikes. Now, the thing that I'm not certain of is whether the 1/1000 is going to be enough to do that. But we will find out here shortly. And you can see that got rid of all but a couple here, all but a handful. Now, these may be caused by the distance. Now that I'm staying a little bit away from there, we can see that we've got some step overs where the distance from here to here is significantly more than the direct distance between each step over, which is my step over is 10,000. So with the on long step over moves, the step to cut ratio set to 2.5. If this is more than 25 thousandths, in this case, it's my step overs 10 thousandths, 2.5 times that is 25 thousandths. If that's more than 25 thousandths, then it's going to retract rather than just stepping over. And I kind of get a feel that that's the issue when it's in a corner or on a big radius where the distance between the starting and end point increases because it's not just in a straight line from left to right or from front to back. So my first option here is to just hit no retracts and see if that gives me any relief on the step overs. In many cases, that is all that you need to do. But if the step over is very large, you may want to go back to on long step over moves and increase the ratio significantly. But you can see that no retracts got us exactly where we needed to be. So we're coming in over here, beginning our tool path, and ending over here with no retracts in between. So I'm going to leave the video at that for right now. That's almost 35 minutes. By the time I quit talking, it'll probably be 35 minutes. So I will leave it at that. I hope this was helpful. And if you have any further questions, feel free to hit me up on YouTube or Facebook, either one, and I will try to answer those. And always feel free to reach out to your GibbsCAM reseller.